So we've talked about Newton's third law of motion, which is for every action there's an equal and opposite reaction. And now we're going to talk about his second law of motion. The second law states an object's force depends upon the object's mass and acceleration. In other words, what he's saying is that in order to move a mass, you need a force. So just like we saw in the video yesterday with the guys with the moving boxes, until they applied a force to those boxes weren't moving anywhere. So let's look at the car. And the equation that we use for the second law of motion is force, which we abbreviate as F, equals mass, which we abbreviate M, times acceleration, which is A. So if you can just remember force equals mass times acceleration, you'll be all set. So here we're going to find out how many newtons it takes to move this 1,000 kilogram car and accelerate it to a speed of 0.05 meters per second, or meters per second squared. So if you were to push this car, which is 1,000 kilograms, and accelerate it to 0.05 meters per second squared, the force that you would have to use to move the car, would be equal to the mass of the car, so our 1,000 kilograms, times the car's acceleration, which is 0.05 meters per second squared. So you would take 1,000 and multiply that by 0.05. So why don't you take a second and go ahead and do that. And in science, you can always use a calculator. So when we multiply those two numbers together, we get an answer of 50. And the units that we use are called newtons. So it's 50 newtons of force. So the units for force is newtons, which is easy enough to remember because this is Newton's law. So let's look at Newton's second law in action. So we have two cars that have the same mass. And we know that the car in the first picture had an acceleration of 5 meters per second square. And our car in our second picture had an acceleration of 10 meters per second squared. So, in the collision with the wall, this car, which had the slower acceleration, hit the wall with less force than the car with the same amount of mass but the greater acceleration. So this car hit the wall with more force than the top car. Now, let's look at, we've got our dump truck and we have our smart car. So both of them are going to be using the same acceleration, so 5 meters per second squared. But our masses are greatly different. Our dump truck has significantly more mass than our smart car. So traveling at the same acceleration or speed, the dump truck is going to hit the wall with a greater amount of force and do more damage than the smart car because it has less mass. So it's going to hit the wall with less force. So let's look at two pitchers. So we have our major league pitcher and we have you. Or if you think that you are a wonderful baseball player, you could think me. So a pitch from a major league pitcher will have more acceleration than a pitch from you or me because the major league pitcher can throw the ball with more force than you or I could. Ooh, and that link is not working. Okay, so remember to go to the Edmodo, to our Edmodo class and do your Edmodo quiz.